Alrighty, well, with all that, let's twist this back around. I'm going to change my little pre-chat, pre-prezo chit-chat. Well, Bob, make that go away. And then I got to change the resolution of the screen ever so slightly, but you can go ahead and get started there, Travis.
All right. So I wanted to start off with a little bit of a recap of the last meeting. It was AJ did a great job talking about async await and promises. And so it was kind of a buildup of callbacks, which are functions that you pass into a function so that it can be invoked at a later time. And then promises are a evolution of that idea, but you're putting the execution context outside of, you're not passing in a promise into a function, you get results out of it. They're kind of known as thenibles. And then async await is kind of a syntactic sugar that came along to really make that process easier, and it saves us from callback hell. And then I also wanted to put a disclaimer that I'm not a callback expert. This was a chance for me to exercise some of my, just use the time in preparing for this meeting and building up some callbacks and trying to get better at it. So quick little recap about callbacks. It was coined by Andre Staltz roughly about 5 years ago. In 2018, he had an aha moment. Andre Staltz is a developer engineer that he's worked on the RxJS library. He's written his own streamable library called Xstream, and he was working on this other one called Y-Signal. So it was going to be kind of like a combination of Xstream and Y-Signal to do pullables and pushables or something like that. And anyways, callbags are a specification. It's not a library. You're not limited to just one callbag JS type of library. Callbag is a specification. So just as a quick little summary of what I'm hoping to accomplish in this meeting is just going through defining what that function signature kind of specification is. An example of writing that spec with just plain JavaScript, no libraries, and a couple examples using some third-party libraries. And then if we've got time at the end, I want to kind of just wander through some of the code that I wrote, and as a group, we can pair code and tweak things and answer any questions and play around with things and learn together. So, I put this presentation up online. If you just pull up callbag.orb.zone, I designed it so it should work on a phone pretty well. All of my slides are like just a few words wide, so it shouldn't have to like scroll horizontally to go through it. And so yeah. All right, so this first slide is, what is a callback? So I've added this little pencil tool that I can kind of circle things on here. A callback is just a function that adheres to this kind of specification. So it's just a function with two arguments. The first argument is the type, and the second argument is the payload. Where, in this next section, so of the types, there's really just 0, 1, or 2, which is either you're starting a new callback, you're either sending data to it, or you're ending that stream. So that 0 type is kind of, a nomenclature is like a greeting or a greet. And then either side that is connected to that callback can send and receive data through that one event, and the 2 event, either side can end the conversation. So the payload for that 0 greeting is also known as a talkback. So you need to not only start a callback, but you provide it like your own kind of, they call it a talkback, like how to talk back to you. So all of this kind of enables, hey Adam, bidirectional data flow. So just for future reference, I've included some links in here. that link out to the GitHub page. I'll just pull it up really quick. My ramblings are not going to explain things very well, but the official repo and stuff, if you want to visit those later, are much better sources of information than my blatherings. So here's what I call a little 10-second example. It's running for 10 seconds. So it should time out here in just a second. Yep. So interject in here, interrupt me. I'm not good in the hot seat. But I'll just kind of go line by line through this code to kind of, this is that plain JavaScript creating our own callbacks. So these are just a couple of constants that we got. So how many milliseconds we want each step to take and how many milliseconds we want it to be done.
And this is just for faking data so that it feels like a web request or something like that, right?
Yeah, well, let's talk through this. So there's nomenclature of a producer callback, like somebody that's spitting out values, and then a consumer. So we're going to create a producer here, and we're going to define a consumer here. So let's step through the producer really quick. So it's a callback, so it's got a type and a payload, so I've just shortened them to T and P. So if T is 0, so if it's being greeted, we're going to just initialize some value X as 0. We're going to just make a more friendly named reference of the payload of, okay, we know that because it's 0, the payload is a talkback. And then we're going to make a little function called step that every time a step occurs, it's going to send a talkback to the consumer or whoever was the other end of that line with that data payload, and it's going to increment X. So every, okay, and then so it's going to create an interval. So I just got a little I reference here. So it's just going to, like, every step milliseconds, it's going to invoke that step function. And then I'm creating my own talkbacks that I'm going to send back to the consumer. So I've just shortened it to TB. And it will have, it only really cares about the type of event. So if my consumer ever talks back to me saying end, I'm going to clear that interval. So it's going to stop doing the set interval stuff. And then it's going to do that greeting. So it's talking back to the consumer, to that original talkback, passing my little talkback to them. And then from the consumer endpoint, it's a lot shorter. If it receives a 0, it knows that the payload's a talkback. It's going to say, after 10 seconds, I don't want to hear anything else from you. So after the done microseconds, it's going to send that talkback to the producer with the end event. Otherwise, if I'm getting a data payload, so if I'm getting a 1, I know that the payload's a data, and I'm, for just demonstration's sake, just console logging it here. And then to tie those two together, I'm invoking the producer, starting it with a greet, and passing in the consumer. So, I don't know, does that make sense? Am I too far out? This is like a little ASCII diagram of kind of that communication flow. So we've got the producer on this side and the consumer on that side. So the start event is that function call. It's getting F as the reference to the consumer. So he starts an interval. So every tick of the clock, it's going to invoke that F function with a 1 payload with a 0, 1, whatever is being incremented as a X. And then the consumer is receiving those values. And so when the consumer gets that greeting with the producer's callback or talkback, it starts a timer. Then after 10 seconds, it stops and it sends that payload back. And you guys, any questions so far? Is that making sense?
All right, let's pause for a second here and just give 30, 45 seconds for people to come up with questions, because I know there's questions, but it may also be difficult to form the question.
So it's not a traditional callback where it's just like one event. It's like you've got this bi-directional kind of like, here's some more data or stop, you know. Somebody has to come up with a question so far.
So just for my own clarification, is it more just kind of like a sort of functional conversation where it's like going back and forth, passing data when needed or
Mm-hmm.
when it's actually requested?
Yeah.
So it's like constantly, almost in a sense, listening
Mhm.
for some type of result, but is it just constantly running a function?
It runs a function whenever you want to pass a message.
Okay.
My contrived example here is just sending a message every second or so, or however many milliseconds, until it receives a stop event. Then it's like, okay, I'm gonna shut down my interval, and
Is this happening without using like a while loop?
yeah, it's just, you know, right here it's every step. So every time a new data request comes, well, not even, so it invokes. Sorry, it starts, and then it's sending off these function calls every tick. And so the first time it sends a 0, the second time it sends a 1, it keeps going, 89, 90, and then finally, after the consumer sends a timeout event, it says, okay, 2, stop, and then it ends. And go ahead.
Is there, so I think one of the things that makes this a little difficult for me is because it's using numbers like 0, 1, and 2, which mean one thing on this side and another thing on that side. And it would have been clear to me if they would have given it the string, you know, an all caps string, or if we had something that was like const start equals 0, and then in the code it's start.
Yeah.
Because that's where it's a little bit weird for me to look at it and try to understand.
Yeah, under the covers there's
process.
0, 1, and 2, but you can definitely have a defined enum or a defined constant that is these kind of friendly variable names. The only reason that my code examples is having these like raw numbers was to try to fit it on a phone size. So like on a phone size, it's kind of like this. So I was just trying to fit it so you didn't have to scroll. But yeah, for readability's sake, it would definitely be nicer to have those numbers be friendly names, variable names.
Because the consumer, let me try to understand this. So producer is only handling greet right now. The producer isn't handling anything else.
The producer creates an interval.
Well, what I mean,
Yeah.
in terms of what
Yeah.
it handles, it
Yeah,
only
yeah.
handles
Yeah.
type 0. Does a
Yeah.
producer ever handle any other type, or do producers only ever handle type 0?
Look in so this talkback that the producer creates on a greet, it creates a new talkback, and that talkback is expecting a message of type end, type 2, and then that will clear the interval. And what's nice about this is it's all encapsulated. You don't have like these global timers and all these global variables that you have to keep this like state outside of it. The producer has everything self-contained in here, that your timeouts and stuff.
Okay, but the producer itself only handles greet. If it's not greet, then it's an error.
It won't error it out. It's just not going to do anything. Like if you send a 2 or a 3 to the initial producer, it's not really going to care. But the talkback that the producer gives back to the consumer, that the consumer talks back to, can receive an end.
Okay, so the talkback, so basically what we're establishing here is kind of like a socket where the talkback is the send, and then the receive is the, because there's two things named talkback there.
Yeah.
So we're saying create. It's like creating a stream, and there's the read end of the stream and the write end of the stream, and you're creating one function that's the reader and one that's the writer, and then you're passing. Yeah, it's a little bit difficult to explain because you got it on both ends, because the producer has a reader and a writer, and the consumer has a reader and a writer, and the producer is what has the data, what has the events that are important, and the consumer is a client to that pseudo socket.
Now, is what he's describing, is that by spec or by implementation? Like,
This is an implementation. The spec,
They can both handle.
yeah, the spec is kind of just generic. This is the convention that you follow: 0, 1, and 2 payload.
But it doesn't matter who's sending what.
Yeah,
It
like
should
it's
work.
up to the implementation.
Yeah.
And so this contrived example is literally just kind of like a 10-second thing that's like, I'm going to increment until I reach 10 seconds and then stop.
Well, yeah, but start, data, end. So it's just like a socket. It's just like a socket. You've got start is connection or on open. Data is like on readable. But what about back pressure then? And then end. But I guess this isn't for large chunks of data. This is for small messages.
It could be for large chunks of data. Like you could code up a back pressure kind of thing into it.
Well, but no one will do that, and then you'll get memory leaks, and then production will crash, and no one will know why.
Yeah. And that's why you don't write these things by hand. which leads me into my next slide. So that's just the plain JavaScript example, right? No libraries involved at all. It's just following the spec. So this next slide, I'm using a community provided library. This one that I'm using is called Callback Common. And it's just a collection of callbags that are pretty common in practice. It's not extensive, but let's step through this. And so this chunk of code is much shorter. Obviously, all of the details are hidden under the covers. The pieces that I'm importing is a pipe function, or a pipe callback, an interval, take, map, and subscribe. So, and then I'm defining this kind of translation mapping function. So it's called num to character. So it's the same kind of behavior as that previous slide where it's just kind of incrementing from 0 to whatever. And then, so I'm just converting that value x plus 5400, converting that to a Unicode character. So let me replay this. Like up at the top, I've just got, oh, dang it. Let's go back to my opening page. I don't know why my route.
Is this working locally or can we, see
Callbag.word.zone.
what is it?
Call.
So the pipe, it's more of a general purpose thing. It's just chaining together the input or the output from a series of functions to the next function. So we're starting with an interval callback. And so this is much like that first slide, but it's just interval, and it's like how often I want an interval to tick off. So every 100th of a second, so it's gonna increment that interval. And then I'm gonna map that result to my little mapping function. So it's converting 0 to 5400, 1 to 5401 to a character code. And then I'm using take to say I only want this to take 150 of those and then stop. And then the subscribe is much like that, invoking the consumer in the producer.
So I haven't used RxJS that much, but for what I have seen, that looks like
Yeah,
exactly like it.
it's similar to it, yeah. So Andre Staltz, the guy that came up with the callback spec, was one of the RX contributors, is one of the RX contributors, and he just had an epiphany of that the signature, because he was trying to find out a way of getting rid of, I can't remember, like the unsubscribe kind of behaviors of it.
Oh, okay.
And the consumer and the producer are really the same signature. You can either push or pull from that whole kind of callback function signature.
So you wouldn't need to unsubscribe from?
You can, yeah. Like this subscribe function from Callbags Common has, it gives you a unsubscribe handler, so.
I guess I'm just confused how they're different.
Yeah.
As far as using them.
The biggest difference is, I think, RX is a big collection of these, they call them operators. So it's a big library of operators, and it's got some legacy to it, so there's a pretty big footprint. I don't know, it's shrunk a lot over time, because after like a lot of these kind of conventions from callbacks and stuff came along, RX6, I think, its footprint shrunk a ton because they started adopting some of these patterns, but they're still.
So is it just implementation is different and like the API is the same?
Yeah, like I don't know all of the details under the covers for RX, but what's cool to me about callbags is at the end of the day, they're just tiny functions. So I've got a link here to that callback common library if you want to dig into it, but this is kind of all of what that callback common library provides. So they break it down into what they call factories, which are things that create new callback streams. So you can either just use of if you've got like an array of things and you just want to turn that into like a stream. You can convert like DOM events from using this from event, and I'll get into that in one of these next slides. You can convert promises to these callbags. So you could have like, for example, like a series of AJAX calls that have to be made in a certain order and convert those results down into a stream. That interval one on this slide that I demonstrated. And then of those factories, then you can manipulate those streams with these operators. So map just kind of transforms the values. Filter will say like you don't want values that, just like map, filter, and reduce, it's filtering out stuff that you don't want to be downstream. Take is that kind of like a limit, like you only want to take a certain amount of events. Start with is like just a convenience way of like if you set up a chain of things but you want it to start with a certain state. Flatten is kind of like an unnesting, because you can create a callback that is a collection of child callbacks, like another kind of stream, and then when you flatten it, it just kind of like brings that branch back into the main branch. Debouncing, so if you want to limit how many times people are clicking on stuff. Scan is just another fancy word for reduce. It's like if you're familiar with map reduce, you're just kind of scanning values into accumulating a single collection. The coolest part of callback common is this expression combinator. You can, I don't know if, I think I've got an example in one of these slides, but looking at this library, 25% of the code was this expression callback. Merge, so you could have, like, say you've got like a stream of button clicks and a stream of mouse moves. You can kind of like merge them so it's one stream of clicks or moves. Combine similar to that, but rather than just always getting any event through the stream, it kind of waits until all of the values have been assigned or whatever, and then you get a combined value. Pipe is that other utility that I demonstrated. You're just kind of chaining functions together. Subscribe is that kind of like you're doing the greeting and starting the listening. Tap is kind of a way of listening at any point of that chain. You can kind of just tap into that stream and kind of get like a side effect to occur, or just kind of debug without affecting the rest of the stream. And then source is just kind of a convenience of like, I may or may not have a value, or I may or may not have a callback that will be converted to a callback. So if you give it like some plain value, it'll make an of callback for you. So that whole library is only 1.8K because they're literally just tiny little functions. So this example, I'll
You
take
still
it.
have this debug stuff open.
Yeah, I'll take all that.
On real estate.
I'll take a breather. Do you have any other questions so far? Is this all still making sense?
It's okay to say no.
I think when you describe it as just a bunch of like built-in little functions, it makes a lot of sense.
Yeah.
It's like the way that node streams, well, I won't say should have been implemented because there's the back pressure problem. That has to be handled implicitly if we're going to do more than just messages. But as far as messages go, this seems like a really, really sane way to do messages.
We should talk about that back pressure problem, because I have no idea what you're talking
guys need more context on that?
Can I take a minute?
Go
to
for it.
explain
Yeah,
Okay,
please.
so when you are on a server, you have a fat pipe. But the things that are connecting to you are phones, and they have a very thin pipe. So you are connected to the internet backbone with a gigabit or 10 gigabit connection, and the phone has a, measured in kilobits, or if it's lucky, megabits connection. So if you want to send some video to a phone, in reality it's going to be done through UDP, and there's some other mechanisms, whatever. But let's just take this example. Videos are big. Phones have small pipe, server has a big pipe. So the client is going to request, hey, can I have that video? The server is going to start reading the file from its external resource. Let's say that the video is stored on the disk for simplicity. It doesn't matter if it's stored on S3 or in a Mongo shard or whatever. The file is big and it's going to come from somewhere where there's a large 10 gig pipe. So then the server is going to make the request to that pipe, whatever that is, whether it's file or S3 or whatever, and it's going to say, hey, could you give me this video? And what's going to happen is that it's going to be ready to give you the video right away. And so it's going to, you are, in the way that node streams are set up, if you use the deprecated data event, then the data is being pushed to you. And this is how nodes started, and most of the tutorials out there still use the deprecated data event rather than the readable event. And so the data event is going to fire whether or not you're ready for it, whether or not that data has been sent. So what you're going to do is you follow this old tutorial, you assign a data event. So the file stream or the network stream is now calling data, 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 data. Meanwhile, every time you receive a chunk of data from the source you're getting it from, you're pushing it out to a phone. And so then on the phone, you're calling write, write, write. Well, the phone is going to get backed up, or if you're lucky and it's using UDP, it's just going to spew tons of UDP packets and the phone isn't going to get most of them. So the phone is going to send back pressure over TCP, if it's a TCP connection, which most connections are. And so TCP has a back pressure mechanism in it, where if there's not enough acknowledgements, that gets back to the network card. And the network card will say, okay, this session, this TCP session, can't handle this amount of data. And so then your network card is going to buffer some amount of data, and then the driver for that is going to stop, is going to say, okay, I can't accept any more writes. And then the application code, when you are calling write, which you're never actually checking what the value of write is, you're going to get a bunch of falses. Every write is going to have a false, but you're not actually checking that. And even if you were, there's nothing you could do about it at this point. And then your data keeps on coming in, and it's not going out. And so that means that it's collecting in that data subscriber function. And so now your memory pressure is growing and growing and growing and growing, and then your app collapses and restarts because it gets an out of memory error.
Okay.
So the back pressure issue is really kind of looking at it from the wrong angle, because what you need is what they returned a pull stream. So instead of listening to a data event, the correct event is readable. So when you get a readable event, then while you read, so you can have a while loop that while reading does not return null, and while writing does not return false, then you write what you read. But as soon as write returns false, then you no longer call read. And then when the writing resumes, then I'm trying to remember, explaining it in words is difficult, but basically you're set up in a situation for success because you're only calling read when you actually can write, and then once everything has been written, you get another readable event.
You could totally set up a callback that's a pullable. Yeah, so you have your consumer that's like, okay, I'm ready for another chunk. I'm ready for another. You can send over that talkback. Say, okay, give me the next one. Give me the next one, and then it would, when it's done, it could then say, okay, 2, and I'm done.
No, I don't doubt that you can't do it. It's just, when I look at this looks very convenient and it looks like a really good standard for message passing. But these as they are implemented, are not implemented with the pull stream mentality.
Yeah.
They are implemented with a message bus mentality.
Yeah.
And message buses, they're small, so theoretically, you're not going to get backed up on memory pressure and have an out-of-memory error that crashes your app when you're message passing, because they're little bitties, and even if, one client doesn't respond right away, you'd be all right.
Yeah. Don't let my contrived examples limit the specification. Like I coded these up as pushables, but it would be good to code up a pullable. Maybe we could do that as a group or something.
Okay.
So this one is an example of composing multiple streams together. So I'll just run this little example right here as it is. Once I hit go, it's going to click off I've got 3 frames per second. It's rotating like 5 degrees as my little mock velocity, and it's going to do it for 10 seconds. So it stopped after 10 seconds, much like that original example. I can tweak this value so it runs at 30 frames per second. I can have it jump 50 degrees every frame. Can have it only last a second. There's a bug there, I don't know. Ignore my bugs. But yeah.
It's the callback spec, it's no good. Let's start over.
So let's step through this code. It's a little bit longer, but it's not very complicated. So I'm pulling some more stuff in from Callbags. I've got a couple more in here, so I have that start with. I'm flattening out some stuff. Yeah, I pulled in that expression as just a little contrived example, and I'm using this from event. So this L is just a reference to query selector, just so that we can get an element reference. I've got some initialized values for how long a second is in milliseconds, what to start with my frames per second, my duration, and my velocity values. This $sign suffix is kind of just a convention to easily kind of visualize the variables that are streams. So I've got this B stream, which is just anytime I click on the button. So yeah, it's just getting a reference to that element and listening for click events. This F stream is my frames per second stream, which is, taking an input event from that input, mapping it to just converting it to an integer from that value. Not that it needs to be converted. And then I'm starting with some initial value. So then I've got a repeat of the same thing but for duration, and a repeat of the same thing for velocity for D and V. And then I've got this just a plain old function that I'm whatever values I've got, I am creating a new stream. So I'm creating a new interval at whatever my calculated rate is based off of those values of the frames per second and stuff. I'm mapping that to some velocity multiplier, and then I'm taking up to however many steps that the duration would be at that frame rate. And then this is just a little like side effect function. So every tick, I'm applying that little rotation, whatever my kind of Z value is. And this is just setting a CSS custom property to do the CSS stuff to actually do the rotation. And so pulling them all together, I'm combining my velocity, my FPS, and my duration stream, and my button click stream. So if you remember, combine won't do anything until all of those streams have admitted a value. And so it was waiting there until I clicked the button. All of these guys already had a value because I started them with a value, but it was essentially waiting for the button to get clicked.
So is this saying, if I have 4 other callbacks, that it will wait for a message from one, and then the next, and then the next, and then the next, and only when all 4 have emitted one message
one or
will,
more.
well, at least one message will it send out, but it will send out the latest message. So if the first one sends 4 messages, and the second one sends 2, and the third one sends 1, and the last one sends 10, it will be just the latest of all of those, as long as each has sent 1.
Yep, exactly. So I've refreshed the page, so I haven't clicked the go button yet, but that all of these changes are new input events. This FPS has gotten a bunch of little events. Velocity's got a bunch of little events. Duration's got some events, and now once the B streams got a value, now it kicks off because they all, what's the word I'm looking for, satisfy or whatever, and then it runs for 13 seconds. Boop. So, and then now that it's already kind of warmed up, any change to any of those streams will kick it again because it's got like a new value coming on that.
Wait, is that through combined?
Yeah, it's all just because it's combined. Combined is smart enough to, if I change this in the middle, it's going to restart. It's going to not only, it's smart enough to unsubscribe from that previous stream and start a new stream with the new values.
Well, why doesn't it wait for you to change all 3 before it starts? 'Cause I
Just
thought
the
it
way
created
that
more event for me.
just the way that I wired it up. You could probably do some smart stuff to, once you run it, like reset the state or something. I don't know, but
Oh, so I think I misunderstood, because I thought it was, once everything is fired 1, it sends it. But is it then?
it's once they have a value in the stream. So when you can create a stream that's just empty. It doesn't have any messages on it yet, and that combine needs a value in that pipe. Sorry, I'm not very good at explaining it.
Okay, so if there's 4 things, A, B, C, D,
Yeah.
each one has had at least 1 value. So it doesn't fire until everyone has at least 1 value. But then after it has at least 1 value, then anytime any of them fire, it will send the latest value of all of them.
Yeah.
Okay, now
Yeah.
now I understand.
And I'm not clearing out these streams. These streams are long living, so they still have a value even after that first kind of event or pipe let it through.
Okay.
And so these ones all started with a value except for the button. So, and then I just threw on this little example, like I want to practice with this expression callback a little bit better, but it takes in this $sign reference, which is kind of like, you can think of it kind of like those string literal $signs, like where you're putting placeholders in a string, and you can,
For backticks?
yeah, the backtick, like string literals. But so you can wrap around any stream and do like computations on them. So this would be like computing the latest frames per second times the duration. So it's just, I don't know, I haven't played with this one much, but it's kind of, rather than writing like these kind of combiners and stuff like that, you can kind of just run an expression with these arbitrary values from streams.
And so that'll reevaluate anytime any of those change.
This is another good link to follow if you guys come across this page again in the future. This is an article that Andre Staltz wrote up that goes through a bunch of this stuff a lot better than I ever will be able to. So let me make this one a little bit smaller. Clear out this log. So this one's a little bit more complex of an example. I've got it so it listens to mouse move events to kind of rotate this little sphere thing that I made, or this little disc thing. And let's step through here. Sorry. So I kind of cut out some of those other callback common things that I'm using, but I pulled in another third-party utility, and this one's called Callback Take Until. And it's not included in Callback Common, but callbacks are composable, so you can, most all callbacks that have been created, they have their own repo. So if you just need 1 or 2 of these, you don't need to pull in a whole library. You can just import callback take until or something if you wanted. So I've got a friction value. I'm making a reference to that little kind of box that's containing it. I'm making a downstream for any time the pointer down or the mouse down or the tap or touch event down. Same thing with the pointer move stream. I've got a little upstream anytime you release it, and I've got an outstream anytime the pointer gets moved out of the box. And then, so I'm kind of composing those together. So I'm creating a start stream. So I don't want to do anything until I get a down event, and then I'm just going to kind of map it to some more convenient values. So I'm hanging onto my friction in the stream just as F, so I don't have to call out to a global. I'm calculating the radius of that container by just dividing its width by 2. This is just a little convention that I was using for a start time is just lowercase st, so that's just a microsecond now. I've got an X, Y, and Z for where I started my down event, the layer X, the layer Y, and then the Z is coming from some external state that I'm using, like from view, for example, of what the last rotation was. And then just for sanity, I'm clearing out what my end time would be. So then I'm tapping into that stream just as kind of like a side effect. So I'm updating my external state, what my current X and Y position are from this drag, this mutated drag. Everybody was still with me?
Wait, go back for just a second. So I zoned out for a second.
Yeah.
Because I was thinking about something else. But the tap is something I've seen a lot. I don't understand what that means. You just explained it, I think. But
Yeah,
what?
you can listen into a stream, but you're not gonna affect it. You use it for like side effects or debugging. You can like console log anywhere in your stream. I could add like a tap here, you know, and I can like console log what my values are. That's what's happening over here. I've got some other taps down further on that I'll show.
So the tap is for.
You can.
You're not going to use that state object. You're just using it for.
I'm updating my external state. So the stuff that I care about in view land, I've got a state object, so I know what my X and Y current position is.
Okay, cool.
And then, so a drag is, it waits until a move event, and it's going to just make some convenient MX and MY for what those moves are. And then an end event is anytime I do an up or an out. So that merge is either or. And then I'm converting that event to an end time and an end X and Y. And so this is my little accumulator function. So I'm converting moves into drags. So every time an event comes in, I'm just gonna like assign into that original accumulator object what the latest values of my drags are.
Okay.
And then I'm either gonna be resuming what that latest state was or starting with whatever the start value was. So if I don't have an at X or an at Y or an at Z, I'm gonna just fall back to whatever the start X, Y, and Z were in that stream.
Okay.
And then if I've got a movement, I know that I can then, I'm just accumulating how much X and Y difference has happened over the drag time. This is just some mucky stuff that with disk rotation, it depends on which side of the north or south side of the, depending on if you're dragging left or right, it's opposite if on the other side. And so I'm creating like a polarity of the X and Y. So I know that if my current at position is beyond the radius or the center point, that I need to invert my stuff. And then my Z rotation, this is just my little hacky way of, just based on the delta, how much it's rotated. So let's kind of interact with that a little. It's not perfect. It's like adding way more than it should, but it's just kind of like, anyways. So then, this is just my little side effect thing that's just updating my external state based off of those. And so, let's see. So a drag is, it waits for a start event, so that mouse down event or the touch, and then it's going to convert those to a new stream of movements. And so it's going to keep taking all those movements, starting with that original down event or whatever, scanning them into that accumulator function that I created, starting with some nulls, and then tapping in to do that kind of side effect. And then it's going to keep accumulating those values until I get my end event. And then this is just flattening that substream, whatever the proper terminology be, into the main branch, the main line.
Okay, so when you say main branch, the drag, where's drag used?
So it's starting with the start event, which then creates a child stream of move events, and then when that completes, it flattens it back into that main stream. So this
there's a
drag.
bouncer in the end? I don't remember if I saw it.
Yeah, I don't think I put a debounce in this one.
Well, how would it know when the movement ends? If
I've got a take until, so this is that other callback that I pulled in, and so it will stop. It will send a stop event once it receives an end or a mouse up.
Oh, okay, mouse up is what? Okay.
My mouse up is either exiting or out of the container or releasing the touch.
Okay, got it, that makes sense.
And
I
so,
understand that now.
and then this is my little, my son actually helped me with this one because I don't know angular velocity stuff, but he helped me write some equations that take the whole start X and Y position and how much time that took and converting that to how far the distance would be and how many degrees that would result in. So,
That's really cool.
and then I've got a spin then it's combining it's waiting for a drag and an end, and then it's gonna,
But I thought the drag already had an end in it.
probably, like a lot of this was just me experimenting. I probably didn't end up needing all of this stuff. The end might just be a safety net in the sense that it's not gonna let anything through this pipe until I've got an end event as well. Like, yes, the movements, the little drag stream. Yeah, I probably didn't need this combined.
Okay.
Yeah. And then this filter is kind of hacky too, and you'll see if you play with this thing. It's kind of fitzy. Like, it needs some love. I threw this together, but what it's doing is so you're getting events, but it's not letting any events through until that end timestamp is greater than the start timestamp. So, like, nothing should make it through this pipe until I've got like an end timestamp. Yeah, and then my little side effect thing. Sorry, I'm bad at it. But so if you
Go a little slower on that because I don't know if it's choppy like that.
it's probably choppy on the screen share.
Here it's choppy.
Yeah, it's a lot choppier than what's happening on my screen. If you pull it up on your phone, yeah, that's really choppy. Or your computer,
Let me
it's
go over here.
kind of funner to play with.
Callbag.org.za. I'm going to use my favorite thing in the whole world here. If this will get out of the way, and it does. Okay. Do y'all know about Text Sniper?
Oh, well, OSX has a bunch of nice image to text copy paste stuff.
Did it spell it wrong?
Just chop off that app. I think my client side routing's kind of broken. Just go to that domain and then jump through a bunch of these slides by clicking that right arrow.
Can I tap? No.
I wish I would have.
Did you use something, or did
No.
you build this from scratch?
I built this all from scratch. It's just a
That's
little
crazy.
even. Okay,
Alright.
so drag and try to spin that,
Okay.
and then do it fast and release. Like, So it's got like some angular momentum, velocity.
That's actually really neat.
Shout out to that.
Yeah, Bass is smart. My son's in college, and yeah, he's a smart kid, doing all sorts of physics and stuff.
Okay. Ooh,
How much time we got?
as much time as you want.
I've just got a couple more slides, and then if you guys are interested, I've got. Well, let's move on.
Well, so I want to pause for just a second. Just honesty. You're lost. Okay. All right. You understand, but you don't know what the use case is.
Yeah.
Oh, disappointing.
Okay.
They're very
I-
contrived examples.
Well, no, I get that. I think I understand this to the point, but that when I have the use case, I think I'll recognize it. But do you have top of mind any use cases where this, either on the server side or on the client side? Well, first, is this more, do you think this is more applicable on the client side or more applicable on the server side?
It's equal.
Yeah.
No, for real. Like server side example. Like I need to stitch together. I've got 4 APIs that I have to talk to. You know, I've got to make an AJAX call over to this
That's
thing.
what GraphQL is for.
Yeah, but without GraphQL, and you say you've got a GraphQL API, and you got to talk to some old SOAP client, and you've got to talk to, you know, like you can build up one of these declarative kind of pipes, saying, okay, once I've got this, then I can, you know, map that to this value and pass that input over to this other API.
So are we kind of, would it be fair to say this is kind of like a state machine?
Yeah,
I mean, we can use it to build state machines?
Sure, yeah, I think because you can accumulate values into that like data object and like say like until I've gotten this AJAX response, maybe retry it 10 times. You know, you can orchestrate these like processing flows very declaratively without like a whole bunch of imperative logic. You're declaring these kind of like translations.
So I'm thinking the value of a promise over a callback is that a promise allows me to encapsulate an event and pass that event around to get the value of it one time. And this looks like maybe this allows me to encapsulate a
Promise.
system of events and pass that system of events around and do combinatorial logic on it.
Mhm. Yeah. So a callback, a promise, like you're saying, it's once it's resolved, it's resolved. You can only ever do a promise once.
But this,
This is like, okay, you're orchestrating a series of events into,
So you can wait a promise several times, kind of.
well,
You-
yeah, you would
you-
create a new promise
you
for
can
this.
await the promise as many times as you want, and you can get back that one value. So the promise can only ever be resolved once. Once it's resolved, it is immutable. There
But
is
this is
no
like,
other value.
So it's more akin to like a generator function.
Maybe, yeah, like you could use it as a generator function. You could do that kind of poll design and say like, okay, I'm gonna wait 10 seconds and try again. And then, oh, I've got a value, so send it down the pipe, and whatever the rest of your data pipe does with that value, it does.
So what I'm thinking is, what a promise does for callbacks, where it streamlines the API of how to do the message passing, the error handling, and the finalization, this does for add event listener. Because add event listener, if I wanted to let something in another part of my code have access to some events, then I'd have to pass the thing that does the event listening around, and I have to break the abstraction. But with this, I can encapsulate the event in a function, a callback that's similar to a promise in its ability to be passed around my application without breaking interface contracts.
I think that's pretty good.
Am I
That sounds reasonable
Am
to
I
me.
hitting it on the head? Okay, so I think it's really important that we not just learn cool things because they're cool, but we learn useful things. I think I'm arriving at how this is useful, and I want other people here to be able to understand why this is useful when they would want to reach for it. And that's why I want to take a minute to see, is there what kind of use cases?
Like a
we-
practical example?
Yeah, can we brainstorm for a minute on how this is useful?
I like the idea of running like a basic, like API request or something like that. That would be interesting. Just kind of, what the syntax looks compared to just like native JavaScript and why it's beneficial to do it this way.
Well, I think the syntax is native JavaScript. Because it's like a callback, right? A callback, you're just defining, depending on if you want to do the node thunk style, it's error and then value, right? Or if you want to do the pure callback style, then it's just value. And you might have two callbacks, one for value, one for error, but then that's pretty much the promise thing. But the function signature, we call it a callback because of how it's used, but we have a standard function signature that we use. So you don't declare a function as a callback. A function is a callback because you use it in a particular context. A callback is an interface. It's a way that we describe how we respond to an event. And I think that that's why this is specification first, is that it is native JavaScript. You're using the ability to create what in some other languages we call channels. You might be familiar with channels from Rust or Go. That's kind of what this looks like to me, is you're using a callback that has a callback that it returns to establish a channel between two pieces of code where the implementation details, so for example, there's browser events. That's not something you use on the server side. There are no DOM events on the server side. And then there are other types of events. You can abstract away what the implementation of the event is. So I'm gonna pull something out of the air, and you tell me if you think this is a good use case. So I want to create either a game where we're sending out events across the network, or maybe better yet, we're doing a help support app. In the help support app, when I click a button on the application, then it responds in some way, does a thing. But if the support rep clicks the button on their application, then that click gets funneled through over to the other side, and then it gets clicked on my application. So if I was using a callback for this type of event, which we could still create it with other event systems, just like we don't have to use the standard callback function signature. We could do whatever we want, but it gives us a way to communicate about an interface of how things are supposed to operate. I could say, I don't care whether this click was a browser event or if this event came from a WebSocket. Either of these types of events, I'm going to have a click callback for, and then whatever that callback has clicked on, whether it's being piped over the WebSocket or whether it's coming locally, the function that needs to execute is going to happen. So I can abstract away the implementation detail of this came from a WebSocket or it came from the local mouse. Does that help or hurt? Is that good or bad example?
I was following.
Yeah,
I get it, yeah. I feel like that was a good way of putting it.
Seems like anywhere, if data's going to change and you need to handle it, that's where you can use this, or like you need to work on, or like do multiple things with that event, then you could use this.
Yeah, state machine is probably a good summation of it, because it's not just like a function invocation. It's like, if I meet all of these conditions that are declared in this kind of like shape, I know that this event will result in.
Because we get callback hell from having to have implementation details of how the function is called and how the function is handled, and then we have to nest them all, and so we have to, call this thing, calls this thing, calls this thing, and there's no encapsulation. All the code is literally written that way. But if we have promises, then you can kind of encapsulate, here's a function, and it creates a promise, and you can pass that promise around. Here's a function, and you can pass that promise around. And so kind of like a promise.all or a promise.race for a single event, you can take this and you can say, well, instead of, we get rid of callback hell, I don't really face event listener hell often, but there are those cases where you do have multiple event listeners, and you do need to know, well, I think that the drag example actually is a really good practical example, because if you were try to implement drag just by listening on events, you have to have global state to encapsulate it, and then you have to register the handlers, and you have to unregister the handlers when you're done, and then you have to calculate the events, and you have to attach it onto the state. So you do the exact same thing that he showed right here, but that you can't take and then export out to something else to use as, here is a drag interface functionality. You would have to create a new event listener, and then you'd have to define the events, and then they'd have to register the callbacks to the event listener. But with this, you can take all of that logic of how the events connect, which needs to wait for what, which ones need to be present, and then you can present that in just a single function that's going to call the callback that gets passed to it with whatever those events are. So it's more native JavaScript than the DOM is or the Node streams are, because it's only a few lines of code at its base layer. And then all of these are kind of like a Lodash essentially for it, but the base layer is just a function signature.
Yep. He gets it.
So is that, now, honest show not following, it's totally okay to still not follow. But you went from totally not following to maybe not following. That's an improvement. Okay. And then understand, but don't understand the use case.
For me, it feels fairly almost preferential, right? Like, how people get evangelical about like functional programming, and like there's values to it, but it's definitely more preferential than anything. It feels a little bit like that, if that makes sense. Like, I'm sure there are use cases, but how much are the use cases like, this makes it better, as much as this is a place where I can make an argument that it makes it better, if that makes sense.
I'm going to try one other example, but it comes from my background in Go. So in Go, it's really easy to create a virtual file system, even before they made it a first-class citizen. Because in Go, there are lots of interfaces, but the interfaces only define typically no more than 3 methods. I think the most complicated interface in Go, well, let's start with the simple ones. Go has a reader, Go has a writer, Go has a read closer, it has a write closer, and then the most complex interface, I think, is the read, seek, write closer. And so a read, seek, write closer, so a reader, you can always just get the next chunk of data. You can just request, I want to read the next chunk of data when it's available. The writer, obviously, similar thing. You can write the data. And then the closer is that I want to read and I want to know when I should close the file descriptor. So if you don't close the file descriptor, it may not write to disk, so you can get corrupt data. You don't worry about that in Node so much because it's kind of already handled as part of the way the Node event system does. But so if I wanted to create a file, if is generally, depending on how you open the file, you typically get just a reader back. And so any place in Go, anywhere in any Go program that can accept a file could just as easily accept a network socket or a connection to a TTY where TTY is when you type at a terminal, the device, the file device is called a TTY. So you basically, in Go, you can take anything that is able to be read and you can pass it into any reader in any Go program. So by having very simple and thin interfaces, it would be difficult to write a program in Go that could consume data only from a file. It's very easy to write a program in Node that can only consume from a file because in Node we tend to not use interfaces as well. So that's where I see the value of this, is that it gives you a way to abstract away from a concrete implementation to something that, because it has a defined interface meaning that there is a signature for what functions are available, what their first and second and third parameter are, which in this case is just a first and second parameter, and then what the return value is. And because you have that identified and specified, you can create event systems that don't have to be tied to any specific implementation. Now, this would have to gain wide adoption for it to get the benefit of Go, but when Go was released, they said from the beginning, part of the value of Go is that interfaces should be small. Don't write interfaces like you do in Java where there's 15, 16 functions. An interface should be able to be described with one or two verbs, essentially. And so that philosophy in Go carried from day one in the very first presentation forward. We don't have that benefit in JavaScript. JavaScript is a very wide ecosystem, lots of different styles of programming. But because this does not require a library, this does not introduce a dependency on any specific bytes to be sent across the wire. It specifies a function signature that anyone can implement. Therefore, without introducing any dependency on any NPM module, you can interact with any other NPM module that does have one of those dependencies without having to force, you're not forced into adopting it. You can provide any implementation that matches the function signature of the inputs, the return, and then kind of this middle piece of what I don't know how to refer to other than as a channel.
Stream is another name.
But I think that it's
Different than a stream.
Yeah, I'd hesitate to call it stream because I think that stream already has a more concrete idea, and when I think of channel in Go or Rust, that's what this looks like to me. But I mean, yeah, it's stream channel. Or, I mean, did I sell you on this at all? If not, fine. I mean, that's my best attempt.
It's interesting at the very least. Yeah. Like,
because you could adopt
I
the
see
spec
what you're
without
saying.
adopting the library. You could choose to write functions in this way and benefit from it as a design pattern without having to adopt code dependency.
Right. Yes. But I think that just describes a design pattern, right? Like, that's the value of a design pattern is that, and I can get behind the idea that a minimal design pattern has value, but like, isn't that the value of a design pattern is that we can all implement it, right? Like,
Yeah, but so for example, promises, there did need to be some pieces of promises that were actually, there was a solid spec in the language for it. I think that this would benefit from language level specification if it's proved out to be a good model.
mm-hmm.
But it has, to me, it has the look and feel of the benefits of a promise across types of events.
Right.
And there is not currently any standard in JavaScript for events. There is a way that has been done in Node and that has changed over the years. We're now at streams v3. That's 3 breaking changes in the stream implementation, or I guess 2 breaking changes in the stream implementation. And then we have DOM events, which have also changed. We have at least 2 distinctly different patterns of DOM events over the years. So we do not have something that is unified. So there would need to be something like, for example, just like we have array dot map, having a callback.map or something in that's actually provided as part of the language would make something like this much more useful.
valuable, yeah.
But even without that, before promises were in the language, the interface was well standardized enough that you could use lots of different libraries and programs together and pass objects back and forth in a way that you were relying on the interface, not the specific implementation.
Mhm.
And so you could say, well, promises are just a design pattern. Are they better than callbacks? And I would argue, hell yeah!
I like it.
You better.
Convinced that easily.
Yeah, yeah.
All right, so this next slide is titled "Sinking Even Deeper." So back to those streams, you get sources of data coming in, and they call it. You send that data out through a sink. And so there's, anyway. So it's just kind of a play because. Wonka.js is yet another one of those userland libraries. So up until this point, I was just using that Callbags common collection of callbags. Wonka.js is a more fleshed out, a little bit more. I just copied and pasted like all of the different, they call them sources for those creation things. So they've got some stuff baked into take observables, blah, 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 from arrays, blah, blah, blah. And then they've got more operators, like so you can buffer stuff, like maybe that might help with back pressure kind of stuff. They got the throttle baked into there. And then these are those sinks, so like subscribing or iterating, like kind of like a for each, much like in arrays for each. I don't really know what publish does. Anyways, so I'm drawing a blank, but there's a library, I don't know, it's called Urkel. Has anybody heard of Urkel? Yeah, I think that's who they named it after, but it's like, what's the one that the competitor? So I'm just making myself look dumb. Anyways,
No, this is.
Urkel is, what's that one that TanStack, like that
query?
Yeah, that query or whatever.
Yeah.
That was that took inspiration from. It's not. I'm drawing a blank. Anyways, it's like that query started off of React query, but now they call it TanStack query. So Urkel is like that kind of convention where it's got like a whole bunch of caching stuff, and it's like you can talk to GraphQL endpoints and stuff like that. Anyways, Urkel is built on top of Wonka. So this pattern is kind of getting out in the wild a little bit. All right, this is my last slide. This is another one of those examples of capturing mouse events, and I'm just doing some CSS stuff to rotate X, Y, and Z stuff. And then I've got this little summary. So this was my best take at a description, just to summarize what I think a callback is. So callbags are functions that can be composed into declarative pipelines that orchestrate series of asynchronous events into managed results. Does that encapsulate it to your taking or understanding?
Yes, I think it's a little buzzword heavy, but yes.
All right.
I personally would not be sold on that description, but seeing your presentation, my eyes have been opened.
And then I've got some more geeky stuff in here. I don't know if me turning the volume up on my machine is gonna hurt anything, but let's try this. Oh no, that's not gonna work.
Can
Anyways.
you just click the mute button on the tab?
It's muted here.
No,
That's
the mute button on the tab itself, like right click,
Oh.
mute or something.
Okay,
There you go.
let's turn my volume back up.
Okay, I also want to see what this thing is, because I'm sure it's quite different if we look at it here. Let's see.
Oh yeah, you might want to like open up in Inspector or whatever so that it like doesn't take up so much of the width. It's based off of the width.
Ugh, responsive design. I hate responsive design.
It doesn't matter. So I've got it wired up. So once I click on it, I'm going to start this.
Whoa! I can install this?
Yeah, put it on your desktop.
Wow! This is amazing!
All right, so I've got a little like event listener that once I click on it, you can't really hear it too well. And it's going pretty fast. Let me turn up my volume.
Oh, that's neato.
So this is a MIDI device, so it's getting MIDI input signals, and I think I just crashed it. I think it was getting too much back pressure.
Using the 1 power.
Yeah. Anyways,
As a male.
afterwards, we'll get into that. But like what I attempted at setting up was that ring device detects like tilt and rotation, and so I used MIDI.js and Tone.js to convert those MIDI events to a tempo, so I can like do really slow boom 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 boom, 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 and then like change the pitch off of the other rotation.
I think you showed this to me once before,
But I didn't tie it into sound yet, so so we can step through that code. But the last thing that I want to wrap this up on, let me refresh this so we get. Oh, I probably totally crashed it. Let me just go back here. Yeah, it totally like kills that browser tab when. You go to Raffle. Oh no, it's not on that. I have to run it from my. It's just a local host thing. So let me close this. Let me pull up this Raffle view. And let me pull up this. Let me kill that one and just start it again. So I've got on my just local machine. Raffle. Come on. There we go. All right, so here's some view code. What I want to do is put everybody's name in this people list. Before we run it, or before we do that, we'll just show what the intent is. So every time we roll, it's going to like cross somebody off the list. It's going to roll the dice, or it's going to re-randomize the list, and it's going to randomly pick an index and cross that person off. So the last person standing is going to win the raffle. So let me get my little raffle prize out. In whatever the proper word is, in fashion of Callbags, I got the best bag. It's a fanny pack. It's a Vivid branded fanny pack.
I really want to win that. I do, because that's what the mic and the stand and the phone will go in for the meetups. All right, I'm winning this.
It's not real.
Why is my
And it's good too, because I'm going to have two, my name's going to be in there twice.
That's why you have two AJs.
All right, so AJ O'Neill. I'll just do AJ O. What's AJ
AJC.
C? Who else we got? We got Adam S. He's my buddy. Thanks for coming, Adam. And Kyle. I guess no last initial.
Emmanuel.
Caleb. It's with a K, right?
And Nathan.
Nathan.
And Manuel.
Manuel.
Oh, Manuel, not man.
Like that?
Emmanuel.
Yeah. And we already got AJ. And I'm not going to... all right. So, well, let me just step through this code so everybody knows that it's fair.
Already gone.
I don't need to be fair, I know I'm gonna win.
So I've got a shuffle array function that's doing, I just copied it from the internet. It's just mutating an input array and changing its order. I'll have a winner when my people list is down to 1. And my roll function is, it's gonna shuffle, it's gonna pick a random index off of the length of that person list, and it's gonna pick out a not name and push that onto the not list. Everybody believe it's all fair?
I'm disappointed.
I'm gonna,
You're not even using
No
callbacks.
callback.
yeah, that's what I was like, oh, I've done enough callbacks for now. Yeah, this one doesn't have to do with callbacks. This is just a raffle. All right, first roll. Everybody has to do a drum roll. Oh, Adam S is out of the game. All right, go do it again. Oh, Nathan's out of the running. Next. AJC's out of the running. Caleb's out. AJ's out.
No, cheater, cheater.
Whoever wins it might give it to you. All right. Manuel wins!
Alright, we got fanny pack now.
Hopefully that was useful.
It's kind of nice one.
Totally do this.
I know I'm gonna sound like the kind of person that I am when I say this, but I learned something.
Good. That's what I hoped for. Here's my raw view code. Oh, dang it, where'd it go? So,
Okay, wait. We need to give, before you start packing up, first comes